we're going to have another 4 keynote speeches plus 1 panel discussion focusing on AI and deep learning. I would like to take a few moments to introduce our next speaker. Himself, he is a reputable engineer who has been leading a group of engineers to work on challenging projects. And now he's mainly focusing on how to apply deep learning to build cognitive robot solutions. So now, ladies and gentlemen, please welcome our next speaker, Mr. Jeffrey Liu. He's IBM Master Inventor. Jeffrey.
Welcome everybody. So my name is Jeffrey, and I'm from IBM Taiwan. And so before I start, I want to give you a little bit background of myself. So in fact, I'm not a PhD in neural network, and I'm more like a system engineer. And in the past 10 years, I was the focus on the high performance server product and the gateway in IBM. So I do a lot of incubation projects and in this area, and I was more focused on the performance of the system, and then focus on how to make a system more scalable and high availability. So for example, if you send any traffic to IBM Cloud today, it will pass through the product I built. So I was leading a development team building on this kind of gateway product. But a couple years ago, I was joining a hackathon in Taiwan hackathon project, and I was using the IBM Watson API and a lot of new tool to build a robot. And we win the hackathon competition. And after that, I found that, wow, this is quite different than what I was built in the past couple of years, because it's a new way to write a program. It's a new way to teach a system. So in this system, more important is how you train a system and how you build a personality that can interact with the environment. So after that, I switched to another group. And so the work we done in the hackathon became an open source project. And I was switched to the group to maintain the open source project. So right now we are using Watson API and that project to help with many Taiwan customers, enterprise customers to build their AI solutions. So that's a little bit background of myself. So that's why I'm here. And I'm currently the cognitive solution and robot architect in Taiwan. All right. So, so today, what I'm going to share with you is my experience of building this kind of cognitive solution. And more importantly, there's another topic I'm very interested about, is about adaptive robotics. So I will talk a little bit about the Watson, and then we will move to adaptive robotics and how this kind of technology can help the next generation robot. So for those of you who have not familiar with Watson, a little bit background about that is that Watson is a system we built in 2011 to join a competition with 2 world champions to answer the quiz contest. So in that system, in that contest, the system has to listen to natural language, the questions, and then generate a lot of hypotheses. What is the best answer for the questions? And what is my confidence for each answer? And depending on the confidence, you decide whether to answer the question or not. And what's more interesting is that in order to win the competition, you need to have some kind of strategy. So, for example, if you have some answer, but your confidence level is too low, then you will probably decide not to answer the question. On the other hand, if the reward for the question is really high, so even though your confidence is not high enough, then maybe you want to make a bet. This can get you to the winner. So that's a system we built at that time, and eventually that system win the competition. And it demonstrates that machine can really understand the question and find the answer in a lightning speed. And for those of you who are interested in this project, you can actually Google this architecture. Internally, we call this a deep QA, so you can find that in the IEEE journal. And we also have a book telling the story of the Watson and how the scientists built this system. So that's the beginning of the journey in 2011. And after that, we look at what function we have in Watson and decompose that function into small piece of reusable API that we want to use that to help customers to build their own Watson. So in 2014, that we formed an organization called Watson Group. So you see a lot of new technology today are starting from that organization, and that is the core technology we use today. So if you look at the IBM Bluemix network, you will see the list of a function that you can use today. So to summarize, there are functions around languages, allow the robot or any intelligent system to understand the conversation context. So this is an area of language. And there's also an area about visual recognitions. The robot can understand what is seen right now, and also some API around knowledge discovery. So you can find a lot of API that could embed into your mobile application today. And if you're interested in building a chatbot, you will find that it's pretty easy to use this API to build a chatbot because there's a lot of Watson API is related to language. This language allows you to understand the intention of the user, allow you to understand the sentiment, the keyword, the topics, and some interesting API related to personality insight. So you can analyze the conversation of a particular user. You can also understand what kind of person that person is. So that will be very useful to build some very interesting application. So these are the API, the building block. On top of that, there are also some reusable software assets. These assets are released in pay-as-you-go software as a service model. So these assets can help companies very quickly to build their AI solution. So for example, there's a Watson virtual agent. You want to build a robot, but you don't have the infrastructure. You don't want to get involved with very deep learning. But you want to have a chatbot to represent your enterprise. Then Watson Virtual Agent was able to allow you to input very easy questions to introduce your product, your enterprise. And then once published, you can interact with the user. And in the backend system, you can see how many people interact with the system and what is the most frequently asked question to the chatbot. So it will get you very easy to into this journey about how to build a chatbot and things like that. And also there are some other solutions as well that allow you to quickly build your AI capability. But if you are really a hardcore company or you are a startup, you want to have a full control of your technology stack, you don't want to use currently off-the-shelf software, then we also have some software offering. In here we have a Power AI platform. In there is a pre-packaged software framework that includes the most popular open source library and its dependency. So you don't have to mess with this software library installation, but instead, after a few clicks, you can install this software in a pre-built environment. And this is not just a software. More importantly, there's a hardware acceleration there. So in there, we have key technology called NVLink. So NVLink, in a standard Power AI configuration, there will be 2 Power A CPU and 4 P100 GPU. And the NVLink was able to provide a very high bandwidth for this GPU to communicate with the system memory. This is particularly very useful because if you do the machine learning, especially deep learning, it's very common that you have to move data between the memory and the GPU. So with this high bandwidth, you can build your model with much less time. So you have a lot of building block from API, from software component, and also from hardware. So next, I'm going to take you through some examples that are very interesting that we have seen in the World of Watson conference this year. So World of Watson conference is the annual conference that people who use Watson library will go there and showcase how they use their system. The first one is in the context of hospital. So imagine if you have a device like an Amazon Echo in the hospital context. So that's what the scenario is about. So we collaborate with a company called Herman. They have a JBL speaker. I think most of you are familiar with that. So we have an initiative with them, and on top of that, we build Watson conversation technology into there. So with that speaker, the patient can ask some questions about, for example, the facility, the hospital, and some basic questions. So this question might not directly related to very professional questions, but it would save the nurse and the doctor a lot of time. And also, because the patient was unable to move easily, so you can use this speaker to control the environment. And if you think of this scenario in other contexts, hotel, it's basically the same. So imagine you have a speaker in the hotel context. You can ask a lot of questions related to this hotel. And if you compare these two scenarios, you will see that it's it's quite similar. And it's useful to build this scenario because in the hospital and the hotel, they are relatively easy to implement this solution. The reason is because first, it's a more quiet environment. So if you ever try to build your DIY echo solution, you will notice that the accuracy is not very high. One of the reasons is because there are some environment noise. And so your speech recognition accuracy will not be very high. But in these two contexts, you are able to control the environment. It's relatively quiet. And the second reason is because the domain. Because in the context of hotel and hospital, the question you can ask is limited. It's not about giving you a Siri that you can ask everything, but they are providing the information for the context. So these are the projects very easy to start, and they can see a lot of benefit from building this kind of solution. Similar to the medical context is last year there was a lady in Japan that got a disease. But a lot of doctors try to understand what is the root cause of the disease. They try different therapy, but they don't see the result. So IBM Japan research team worked with the Tokyo University to put the DNA of the lady and the past treatment into the system. So the system was fed into 20 million medical documents, research papers, and by comparing the feature from the input and this medical document, in 10 minutes, the system was able to identify the lady got a very rare leukemia. In Chinese is called 白血症. So the system provides very effective suggestion. So these are the very good example that an intelligent system was able to do something that a doctor cannot easily do. But they are not making the final decision because doctors still own the power to make the final decision, but they assist the doctor to read this huge amount of document. The same applies to other contexts as well. For example, lawyer, they have to read a lot of regulation documents. So if a system can help human to understand this regulation, they will save a lot of time. Another very popular area would be the autonomous vehicle, the smart car industry. So there's no doubt that it's going to be a very complex platform that people want to put a lot of AI technology in there. So you see a lot of automotive company spend a lot of money to buy the stuff, to get their key self-driving technology. But from IBM perspective, what we are more interested in is the smart agent on the car. So the agent will be able to provide suggestion for routing, will be able to answer questions about the traffic. And you can monitor all the sensors in the car and provide some real-time warning if there's any. So this is a very interesting area because by doing that, the system was able to answer a lot of questions the driver was want to ask. I'm not sure if you have this experience. When you're driving, your hand was on the wheel, so you don't have much control of other device, but you can speak. So if you can interact with the system in a natural language, then they can provide a lot of information you need in real time. So apply the same context to the bus. So last year in the Washington, D.C., we have embedded this kind of conversation technology to work with a local company called Local Motors. Local Motors is, they use 3D print to print the first generation of the bus. And then we embed Watson technology in there. So without further ado, let's take a look at the show video.
Hello, my name is Ali, and I'm making history. I am the first cognitively enabled vehicle. I seat 12 passengers. And you can ask me anything. I'm what's next in automotive innovation. I come from J&D engineers at Local Motors.
Local Motors is a technology company that it's here to revolutionize a 120-year history of the way that vehicles are made.
I still remember the first time someone told me about Local Motors and they said, we have a 3D printed car. And then I saw their vision in projects like Ollie.
You're going to see this shift. You're going to see the vehicles become more highly automated, ultimately autonomous. You're going to see vehicles become cognitive. And so Watson IoT Auto Lab is very much around the future of that cognitive experience.
And the best part, this is just a start. I'm about to go global.
It was very exciting to us when IBM approached us and said, could we partner with you in putting Watson IoT into one of your vehicle sets, and could we do it quickly?
And you have to be able to ask questions. Just like my passenger asks me, are we there yet? You can ask Ollie these same questions.
The world of IoT is moving at lightning speed. The only way to stay ahead of that game and to be a player in that game is to be able to innovate as quickly as possible, be able to assemble and deploy solutions as quickly as possible, and that's what Local Motors is trying to do, and that's definitely what IBM Watson IoT is doing.
Well, so long for now. My name is Ali. It was sure nice to meet you.
All right, so Ollie was released in 2016, but it's going to production by the end of this year. So there's a German company called German Railway Company that already decided to release 50 Ollie bus in German. So we are looking forward to see that in Taipei soon. So in another industry, agricultural industry, that's the area that Watson IoT and Watson technology can help. So there's a startup company called SenseAg to use Watson technology to monitor the farm and to identify the area that farmer need to take special actions. So they basically build a warning system that allows the farmer to know which area has problem. And another company called Aerotronic, in the Netherlands company, they put the Watson visual recognition into the drone. And it could be applied into many use cases, but one of the most important one is it helps some technician to reduce the risk, because in the past, they have to climb up to the power tower in order to inspect some equipment to see if there's any problem. and that is very dangerous. But with the drone, they was able to take off anytime, regularly, to inspect if there's a problem. And only if the equipment has some problem, they will send notification to the technician for follow-up actions. So this kind of drone can use in many use cases, like social security. They can identify which area has violence. They can also help the company to, for example, repair airplanes. So a lot of interesting scenario if when you combine drone and the visual recognition together. Another area is about security. In the security, as a security engineer, you have to inspect a lot of blog and the security bulletin in order to identify some security threat that related to your enterprise. What if there's a way that there's a system can read all the security report online and also correlate that with the system log generated by your infrastructure. And then once there's a match, then they can provide some suggestion. And by doing that, the security engineer can really focus on how to provide a patch for the system instead of reading a lot of source, because you will eventually miss someone. So that's a good example showing that human and machine can work together. So people still the one make the final decision, but a lot of tedious work can rely on the human, rely on the machine to do the investigation, to do the digest. All right, so this is what we call the augment human intelligence. So when we talk about AI, IBM's interpretation is not artificial intelligence, it's augment intelligence. So if you look at all the examples I just mentioned, it's about how the system can provide relevant information to the user by reading a lot of data, how to train a model for that particular use case, and how to communicate with user using the natural language. So it is trying to enhance the intelligence of human to allow human to do things more efficiently. That's a focus of what we are doing. So, but there are still some challenge, especially in the industry domain and the enterprise context. The first one is you don't have much data when you want to do the deep learning training. So this is a very big problem, especially when someone tries to release new technology with deep learning. Not every, it's not like an image. We have a lot of high quality labeled image. In a business context, you don't have much data, and most of the data are unstructured in PDF, in PowerPoint. And how we can build a knowledge system using this data, it will be very challenging. And the other challenge is that the machine learning result and the deep learning model we see today is more like a black box. The black box cannot answer clearly why the result was generated, because we can only trust that there are a lot of high quality training data, but the result is not something we cannot control. So for example, you go to a bank, you want to apply for mortgage, but the system tells you that you cannot apply, and then you ask why. The system cannot give you any reason. This is really upset. So this is the area that our research team are focused on, how to train a system with much less data, and how to provide a very clear process of how this model was trained so that you can give the answer, you can tell the customer why. So I hope this kind of occasion can give you some ideas. So it's not about telling you that you have to use Watson to build intelligent system, but it gives you an example how people can use the intelligent system, how to use this API to create new business in particular industry domain. So if you are interested, you can go to, there's a website, World of Watson 2016, and there are much more examples here. So I hope that can get you inspired to create some new interesting applications. All right, so another very interesting topic I'm looking at is about adaptive robots. everyone loves robots, and it can help us to do a lot of tedious work. And this is especially in the context of manufacturing. But with all the advanced technology we just mentioned, we basically provide robot a better eye so that it can understand things, it can see things more clearly, understand what is the object in front of it. And we can get in more sensor data, and so they can make sense of this data, this sensor data, and understand what's the next action to do. And then they can use grasping technology so that they can grab something they was unable to do that. So just for example, if you ever watch the Amazon robot contest, in the past, the contest is about to grab something into the bucket, but they tell you what object to grasp. But recently, this year, the topic becomes they want you to grab 40 objects into the bucket, but they only tell you 20 of them. The other 20 item was disclosed 30 minutes before the contest. So if you don't have a training model, if you don't have a systematic way to train a system to do that, you will not win the contest. So this is the very good example of how the robot need to be adapted to different environment. And also the language, the speech recognition and text-to-speech give the robot a natural way to communicate with the user. So in the past, if you want to adjust the behavior of the robot, you have to change the program. But if the robot was able to understand your command, then you were able to tell the robot, this is right or this is wrong. And based on their internal algorithm, maybe based on the reinforcement learning or deep reinforcement learning, they change the weight for different decisions. So gradually, they learn how to do something correctly, and they optimize their actions. So this is what we call adaptive robotics. And finally, with the advanced technology, we see robots can move around. They do more smart path planning. So I think in the next couple of years, you will see the robot is more than just a robot arm or do some very dumb action. They gradually learn and pick up new skill. So if you compare writing a program for robot and writing a program to traditional system, it's like when you're building a traditional system, in order to add additional functionality, you have a plug-in infrastructure so that you can put a new module into the software system so that the new capability will add. But in the context of robotics, what you provide is a new skill for the robot. But you are not giving the final result of the skill. You provide the robot to, for example, grasp. But once you install the skill into a robot, they have to practice. They practice to fit the context for the environment so that they can master that skill. So you will see they level up. Like a game, you are building a character with more experience. So this kind of the concept will, when combined with the deep learning technology in vision, language, and a lot of action control, you will see the robot is getting more and more smart. And if you look at it, the right-hand side there, oops. If you ever see a movie, Bluemix, and you will see this kind of a miniature small robot. And it's still not very common today, but I believe that it's going to play a very important role in the future because this represents a group of robots to perform a special task. For example, disaster rescue, or they are building some small buildings using 3D printer. So you have a multiple robot, but they have to share the same brain, share the same intelligence. So this is called swarm intelligence. So they learn, they act consistently. And so it's not individual robot, but a group of robots to fit the context. So with the help of advanced technology in deep learning adopted robotics. So this is a very good foundation for next generation talents. So what's missing is the idea. How you apply this into different industry. The industry haven't applied this kind of technology yet. How they can take advantage of that. And how we can build new talents that can really harness this technology, the benefit provided by this technology. So this is the next very important issue. So we see a lot of challenge here, but definitely we are more exciting to see what's going to happen next with this old technology. All right, so that's my presentation today. Thank you.